Okay, hello everyone. Today we are going to look at a new concept. It's called factorial.
A factorial.
Do you know what is a factorial?
So, uh, for example, 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And
That's
so on and so forth.
that's correct. But let's look at when do we need to use it and where it can be useful. So sometimes you will see problems like this. Look at the first problem here.
How many different numbers can you form using 1, 2, and 3 if you can repeat numbers?
So how about we write this down and see how many numbers we form. So
3,
so I think the first number because I can repeat them, I can think there is going to be 111.
2, 2, 2,
Correct? No, we'll start everything that starts with one first. Then 1,
1,
1,
2,
2, 1, 1, 3. 1, 1, 3. And we goes to 1, 2, 1,
2,
1, 2,
3.
2, 1, 2, 3.
It takes a lot of time.
But yeah, but like for this example, let's complete it so we understand the whole concept. So now that like have we exhausted all the numbers starting from 1? Yep.
No.
No. So which is the next number?
1,
1, 3.
1,
Yeah.
1, 3, 2, and 1, 3, 3.
Correct.
That's a lot of numbers. So
Yes. So how many numbers we count so far? 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the numbers that starts from 1 are
nines.
9.
Since all the numbers that start from 1, there are 9 numbers that start with 1. There must be 9 numbers that start with 2 and 9 numbers that start with 3.
That's correct. So we have how many numbers?
We have uh, 27 numbers.
27 numbers, right? So here let's see what were the keywords that you can repeat the numbers. So repeating is something that's why we could have 111 or 112. And so this was easy because we had only three numbers. We were able to count them and add them, and they end up in 27.
What if you had 5 numbers?
Yes. So when you can repeat the numbers, there is an easy way to think about this is you can see how many numbers are there. So how many numbers are there? Three.
Yeah.
And we are looking at three possible combinations. So here you can actually multiply 3 into 3 into 3 three times, and then you get that numbers
3 into 3
into
into
3.
3 is 27.
27. So when you don't have to repeat the numbers, you can multiply them to themselves as many number of times.
No, when you can repeat.
You can repeat number. So if this has have been 4, then you could do 4 raised to 4 or 4 into 4 into 4 into 4, and that would have given you the answer. Yes, or 16 square. What 16 square?
Square.
Don't remember? No, 16. All right. So this is not factorial. This is where like we are still focusing on when you can repeat the numbers, you can find easily how many possible ways to do it by just multiplying the number by as many times as the value of the number.
Mm.
So now let's go to the second one. Now we add a little bit of twist.
How many different numbers can you form using 1, 2, and 3? But you cannot repeat numbers.
Yes, if you cannot repeat numbers, many of the numbers that we use here will not be possible here, right? So if we start with 1, 1 cannot repeat. So it have to go to 2 and 3. So let's see all the possible numbers that we can start
And
with.
one,
We start with 1 is 1. There are only
two.
two possible numbers. What about starting with 2? Same thing.
30, 230, 231.
And again starting with 3, there are only 6 possible numbers. So if we So this one, like because the number was small, we were able to do this by Brent easily. But when you see these numbers that like you cannot repeat and you have to arrange certain numbers, then the concept of factorial kicks in. So instead of doing all this, there is an easy formula like how we learn the formula in the previous place, where like we have to multiply the total number in total number of times. Here, what we have to do is do we do it something like college, because there are three numbers. We do 3 factorial. And how does 3 factorial work?
3 times 2.
3 into 2 into 1. So whatever the number, we start multiplying by a smaller number until we reach 1. So 3 factorial is 3 into 2 into 1. 5 factorial is 5 into 4 into 3 into 2 into 1.
So it's like n minus 1 and then n minus 2 and then n minus.
Correct.
So n times n minus 1 times n minus 2 times n minus 3 so on until
N
n
equal to
is n minus n. I mean not n minus n minus
1. Yes, until we reach 1. Okay, that's good. So let's look at next 3 problems and see if you can figure out, is it a case of like a first one where we keep multiplying number itself, or is a case of second where we have to uh, reduce number each time that we are multiplying. So how many ways 4 students can stand in a queue? Is it a problem of, is it a problem like first one, or is it a problem like second?
What about if a bicycle lock has 5 numbers? How many possible combinations are there for the lock?
The first, what do you think the first one is? This one, fourth one.
So, uh, if 4 students can study, I think it's more like more like the second one because you can't somehow like clone a student or something.
So once a student stands at one place, that student cannot again stand in another place. So this is a problem very similar to this one. Like cannot repeat.
Because because you can't just clone the students.
Right.
You don't have a cloning machine.
So that's why we have to do here is the answer is 4 factorial. What is 4 factorial? 4 factorial is equal to 4 into 3 into 2.
Which is 24.
24. Right. What about the bicycle problem? If a bicycle number,
So uh, if you have 5 numbers, how many? Here you can repeat numbers because if how many possible combinations are there for the lock? It's like you can have a password which is 555. You can have five.
yes, that's correct. So this is similar to the first problem. So it is what we have to do is 5 multiply itself 5 number of time, or 5 is to 5. And let's go to the last one. How many words, doesn't have to be decreasing words, can you make?
ABCD. Using ABCD, if you have to use each letter only once,
Yes.
the keywords are only once because that it means.
Okay, let me just see. How many 4-letter words?
Only four. Oh yeah, 4 letter. um, Only once. So and immediately you can see only once means uh the question number 2. So you can easily.
Yes. It only means what they are asking is that you cannot repeat the numbers. If you cannot repeat the numbers, then immediately what should come to your mind? It's the problem of factorial,
Yeah.
right? So to see this in way that usually we write in mathematical form is, if the problem is like first one, then we say this is n raised to n kind of a problem. So this is, we have to multiply n number of times, and if it is a factorial, then it is n factorial problem. So n raised to n is more than n factorial because n factorial, the value of n keeps on going down. All right. So that concludes our factorial problems. Maybe in next few videos we can solve few more. But for now, that's it. Have a good day. Bye. Hello, everyone. Today, let's quickly look at some of the problems that you might face, which includes some number understanding around repetitions. So you might have some problems like this. Let's look at 1A.
How many possible arrangements is six face? One six face die is rolled one time.
So this,
So a die, uh, the singular form of dice.
yes. So a die has typically six faces, and each face has numbers ranging from 1 to 6. So the here question is that like if you roll a die, like what are the different ways in which the die will end up with face up? So
Six ways.
so there this is easy to understand. It could be either die will result in 1, 2, 3, 4, 5, or 6. So that's how you know that it is 6. So here we can say that there are 6 possible ways that die will end up. How about if I roll a die twice? What are the possible ways that as a combination of first throw and second throw, the numbers will result in? To give
It will be one, one, two.
So let's say if I throw a die first, it can be number 1, and when I throw it again, it can come as 5. So that is the result of throwing two dice. So that is one possible result. So what we are looking for at how many such numbers are possible? So something like, let's say there is 1 1 1. Then once you throw one, the second time it is two. So the question is how many possible such combinations are there? If we have to write it down like 1 1 1 2 1, it will take us forever. But there is an easy way. Do you know what is the answer? How to do this?
6 times 6.
6 times 6. Yes. So here the answer is 6 into 6. So there are 36 possible combinations. So let's take it a bit further.
Oh, it's the equal sign. Okay. Yeah.
30, 36. Good. What about if I roll the die three times?
It will be 6 times 6 times 6. So 36 times
36 times. So that is the correct answer. It is 6 into 6 into 6. But looking at these three examples, you can see that there is a pattern forming. At the base,
So kind of like 6 rolled one time. So 6 is like six is like the 6 into itself. So since there's always a factor of 1 in any multiplication problem, it's like 6 times 1, 6 times 6 times 1, and then it all becomes 6. So that's how it's just 1. So
right. So here you can see that when we're rolling it only one time, it's 6 raised to 1, and the answer was 6. When we rolled dice two times, it was 6 raised to 2.
power is how many times you roll it.
Yes. So anytime you get a question like this where you have n number that they have given in the original, and we are trying it for r number of times, the easy way to remember is the answer will be n raised to or n the power of r, where n is like in this case the number of faces for the die, and 3 is repetitions. How many times are we repeating? So n raised to r. With this in mind, let's go to a little bit more complex problem. Okay, let's look at 2a.
How possible arrangements are there uh, if string is formed with 3 letters followed by 4 numbers? For example, ABC 1, 2, 3, 4, and so on.
Okay, so here what we are saying is first three first three characters of that word or that string are letters. letters range from which number, which to which?
A to Z.
A to Z, right? So let me write this. A to Z,
A
A to Z, A to Z. And the next,
Not notice they did not say that you couldn't repeat the
yes.
letters or numbers.
What about numbers? They can range from
To
0 to 9.
0 to 9 till 0 to infinity.
0 to no, it's four numbers, four digits.
Okay, 4 digits, but 4 digits there.
Okay, you're right. I should change this to four digits. Okay. So here the idea is that like first first character of the string there are A to Z. What how many are this? A to Z means how many possible ways to choose first letter?
There are 26.
There are 26 letters. So we can choose the first letter in how many ways? 26 ways. And for each wave that we choose the first character, how many ways to choose the next one?
26.
Into 26. What about the third one?
26.
Into 26. What about the
9 into 10 into.
correct? So there are nine. So first one has there are 26 ways to choose first character, 26 second, 26 third, and there are 10 ways to choose the first digit. Then I get 10, 10, 10. So this becomes into
1000.
10
1000.
into
1000.
10.
That's
Are you sure?
oh, the 4 then put 10,000.
10,000. Okay. So easier way for me to write is it is 26 raised to
3
3
times
into
10 raised to 4.
10 raised to 4.
10 raised to dollar sign.
10 raised to 4. That's correct. Okay. So now you got it. Let's add a little more complex. Let's make it a little more complex. How many possible arrangements if first letter is A, then what changes will we have to make?
We will have to put instead of uh, A to Z, A to Z, A to Z, and 26 times 26 times 26, you have to put first letter always A.
So I change to A. Anything changes after that?
No.
Right. So
Yeah.
so what do I need to change from our this formula?
1 times 26.
So the first one becomes 1.
Which won't do anything though.
It will right. So it will change this to instead of 26.
It, uh, it will be fine if you like.
Don't write 1.
Yeah.
So this one just goes to 26 raised to 2.
26 raised to 2, it's much smaller than 26.
So that is how we look at the some of the repetitions problem, which are straightforward. Um, Next time we'll look at more problems where there we have to use permutation and combinations, and then we'll explain what is permutation and combinations. Thanks for listening. Have a good day.